Hey everybody, Mr. Covey here. And today we're talking about graphing exponential functions. So we've been talking about writing exponential models a lot, but we haven't talked about what those graphs look like. So I think the best way to get a feel for this at first is to make a little table. So we're going to make a table for y equals 2 to the x. If we make a little table here, and we stick in some x values, and we'll see what y values we get out with them. So if we plug in 0, 2 to the 0, well, anything to the 0 power is 1. If we do 2 to the first, we get 2. 2 to the second, we get 4. 2 to the third, we get 8. 2 to the fourth, we get 16. So as we've talked about a bit in class, what you see is happening to our y values is they're doubling. Okay, so let's plot those points real quick. See what this graph kind of looks like. 2, 4. Oops, I'm sorry, I plotted that wrong. 0, 1, 1, 2, 2, 4, and then by 3 we're all the way up to 8. So it'd be like right there. Okay, so this graph looks like it's swooping up like that. It'd be helpful if we plugged in some negative points if possible. Let's plug in -1 for x, and let's remember how negative exponents work. So 2 to the negative first, a negative exponent flips it into a fraction, so it's 1 divided by 2 to the first, so it's 1/2. So when you plug in -1, you actually get out 1/2. When you plug in -2, well, that's 1 over 2 squared, so that's 1/4. -3, we get 1/8. We'll continue to get smaller and smaller fractions as we go further and further negative. If you see these points here, and we connect them, what happens is we get a graph that looks like this. Kind of like a rocket sound because it shoots off. And that's what our exponential graph looks like. A couple of things to note. It does not ever hit the x-axis. It doesn't hit that. The reason it doesn't hit that is because if you ask the question 2 to what power is 0, you can't put 2 to any power and get 0. Even if you put it to, first of all, if you put it to the 0 power, you just get out 1. But even if you put it to a really big negative number, like -100, way back here, what you get is 1 over 2 to the 100. 2 to the 100 is a really big number, so 1 divided by a really big number isn't 0, it's just a really small number. So what happens as you go this way is it gets really, really small, but it never actually hits 0. Okay? We'll talk about this idea more in class, but there's a name for it to get really close to something but not touch it. We call that line an asymptote. So all this is a line that the graph gets really close to, but doesn't touch. Can't touch an asymptote. Okay. If I was going to describe that purple line, it's a horizontal line. So it's going to look like y equals, and it's y equals 0, because it's at a y value of 0. Okay. The domain for this is all real numbers. If you're thinking about the equation, you can put 2 to any power. You can put it to the 100th power, you can put it to the -1,000,000th power, you can put it to the 3rd power, you can plug in any x you want. Now the range, remember our range is up, down. The lowest this graph goes is 0. The highest it goes, well, it shoots off to infinity. It doesn't hit infinity, can't hit infinity. Does it hit 0? No. Okay, because of that asymptote idea. It never actually hits that line. It just gets really, 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 really close to it. Okay, and that's what our exponential graph looks like. shooting off like that. There's a couple other problems I want to look at. So let's slide down. If you look at this graph, y equals 2 to the x minus 1 minus 3, it is just like y equals 2 to the x, only there is some transformations that happen. Remember, we've talked about transformations a bit. They are shifts left, right, up, or down, or maybe stretches. In this case, we just have some shifts going on. So this minus 3 is on the outside, so it's going to move my exponential down 3. The minus 1 is like in the exponent, so I kind of think about it as being on the inside of our function. So it's going to move it horizontally, and it works backwards. So that minus 1 is actually going to move it right 1. So this graph should look exactly like this graph, shifted down 3 and right 1. Now there's a few ways to actually do this process. Maybe the best way would be to just make another little table. Okay? Maybe when we get better we won't do this, but for now I think that's a good idea. I'm thinking about x values that are going to be easy to plug in. Because of that minus 1, it might be better to start at like 1 instead of starting at 0. We'll talk about that. Alright, so if I plug in 1 for x, 2 to the 1 minus 1, well 1 minus 1 is 0, 2 to the 0 is 1, 1 minus 3 is negative 2. 2 to the 2 minus 1 is 1, 2 to the first is 2, minus 3 is negative 1. This would be 2 to the second, which is 4, minus 3 is 1. Let's plug in a couple more. If I plug in 4 for x, that's 2 to the third, that's 8, minus 3, that's 5. Let's plot those points. At 1, I'm at negative 2. Oh, I'm plotting points wrong. Not good. Alright, 1, I'm at negative 2. 2, I'm at negative 1. 3, I'm at 1. 4, I'm at 5. And I'm starting to see that rocket shooting up there. Maybe I should plug in 0 just to see where we're at. So if I plug in 0, this is a little tricky. It's 2 to the 0 minus 1 minus 3. Well, 2 to the 0 minus 1 is 2 to the negative first minus 3. 2 to the negative first is 1/2. 1/2 minus 3 is negative 2.5. So at 0, I'd be at negative 2.5. If you look at our graph now, and the shape, shooting off like that, and you can kind of see it flattening out here, and the line that it's flattening out at, the horizontal asymptote, you can see is at negative 3. It's important that we put the asymptote on there, even though it's not really part of the graph. It's important to put it on there to let the person looking at the graph know that's the line it doesn't touch. It makes sense that the asymptote's at negative 3 because we moved down 3. So if you look back at our first example, the asymptote was at 0. So if we take that graph and we move it down 3, well, the asymptote's going to be at negative 3. So we have this line, that yellow line at y equals negative 3 that we don't touch. Our domain is still all real numbers. All exponentials have a domain of all real numbers. And our range, the lowest we go is negative 3. The highest we go is infinity. We don't touch infinity, and we don't touch negative 3. We just get really close to it. As you get more comfortable graphing these, it's possible that you might just know what this looks like and be able to shift it down 3 and right 1 without making a table. But making a table is always a good go-to play. Alright, I want to look at one other example, and then I'm going to leave you the last one to do for class on Monday. So for this one, you'll notice something a little weird, which is our base is a decimal. In other words, our base is less than 1. If you remember your base being less than 1? The thing's not actually growing, it's decaying. Okay, so our graph's going to look a little bit different because our function is decaying. And let's see how that plays out. We'll make a little table. Let's plug in some x's. Let's plug in 0, 1, 2, 3, and 4. If I plug in 0, what's 0.5 to the 0? Well, that's 1. 0.5 to the first? It's 0.5. 0.5 squared. If you are having trouble doing 0.5 squared, maybe it's helpful to think about 0.5 as a fraction, 1/2. You guys know that. 1/2 squared. Well, remember when you square a fraction, you square the top, square the bottom, square the numerator, square the denominator. Square the numerator, 1 squared is 1, 2 squared is 4. So at 2, you get out a fourth. At 3, well, 1/2 cubed. That's 1 cubed, which is 1, over 2 cubed, which is 8. We're at 1/8. 4 should be at 1/16. Let's pop those points. 0, I'm at 1. 1, I'm at half. 2, I'm at an eighth. Sorry, 2, I'm at a fourth. 3, I'm at an eighth. 4, I'm at a 16th. This is looking kind of weird. I kind of get what's going on here, I think, but let me plug in some negative x values. Let's plug in -1. 1/2 to the negative first power. Be careful here. I gotta flip it. When I flip that 1/2, it becomes 2 over 1 to the first power. Well, that's just 2. -2. Okay, I'm gonna take my 1/2. I'm gonna flip it. And then I'm going to square it. I get 4 over 1, so I get 4. So at -1, I'm at 2. -2, I'm at 4. Oh, I get it. This graph isn't shooting off like a rocket. It's like, it's dying, it's decaying. So instead of swooping up, it's swooping down. It's not shooting off and going up really high in value. It's going down lower and lower and lower and lower. It's our decaying graph. So if you think about some of the models we've looked at where things have gone down, 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 down in value, that's what it looks like. Domain, still all real numbers. Doesn't change because it's decay instead of growth. Our asymptote, that line that we get close to but never touch, is still y equals 0. I know I kind of drew it like it touched it. Not good, Mr. Cuddy. Not good. Doesn't touch it. Just gets close. And range, up, down, the lowest it goes is 0. The highest it goes is infinity. Can't touch infinity, and we don't touch 0. Okay, so if your b is less than 1, your graph is decay, and really, it's going to swoop down instead of swooping up. Alright? Okay. For Monday, if you could give number 4 a shot. We'll talk about it at the beginning of class. That's it. Have a good rest of your weekend. Thanks.